Good morning, good afternoon, good evening everyone, and welcome to our BT Diamond IP webinar. I'm Michael Dooley, Vice President of BT Diamond IP Operations, and I'll be your host on today's webinar. Today's topic is Accelerate Cloud Automation. The cloud is transforming the way organizations offer and support computing and communication services to their users and constituents. Cloud computing enables IT or service provider operations teams to provide dynamic network computing and services capacity with flexibility, efficiency, and elasticity. But with these benefits comes additional administrative requirements. Tracking IP address space across multiple domains, including enterprise, private cloud, and public cloud, can present several challenges for IT and operations organizations. In addition, with every virtualized function requiring an IP address upon instantiation, automating address assignments becomes paramount to maximizing cloud benefits. This webinar will discuss the critical role of tracking IP address space and how automation can improve cloud operational efficiencies. Today's webinar will feature a 40 to 45-minute presentation discussing these topics, followed by a brief question and answer period. To ask a question at any time during the webinar, you may type in your question in the chat pane on the WebEx application. We will hold all questions until the end to maintain the flow of the presentation. We're happy to have Tim Rooney with us here today as our presenter. Tim is our Product Management Director and is responsible for directing product and feature development, supporting sales and marketing, technology development, and otherwise supporting product-oriented organization functions. Tim has authored 2 books on IP address management and has co-authored 2 with yours truly, with our latest book covering DNS security management published by Wiley IEEE Press. With that, I'd like to turn it over to Tim to begin today's presentation. Over to you, Tim.
Okay, thank you, Mike, and greetings also to everyone. Thank you for joining the webinar today. Hopefully we'll be able to convey some useful information to you about automating your cloud deployments from an IPAM perspective. So as we do normally, we asked you a question when you're registered, and basically, what are your plans for cloud network services implementation? Looks like about a little over 40% plan to use spreadsheets, using cloud DHCP and DNS services to automate address assignment and name resolution. Another 18% using an IPAM solution. 11% homegrown, and 8% are undecided. So kind of a mix there. A lot of folks using spreadsheets. We'll talk about the automation aspects and the benefits of using an IPAM solution in the over spreadsheets in the presentation today to hopefully convey the necessity of automating to really leverage the benefits of cloud in terms of that the agility, shall we say, of being able to deploy resources. But we'll get to that as we talk about the cloud terminology and benefits. And then we'll talk about cloud networking a little bit in terms of just basics, very high level, IP address space and who's managing what and how do you track it. Automating cloud operations, we'll talk about how you might look to automate those operations in the cloud, again, to take advantage of its, leverage its full benefits. And then we'll wrap it up at resources and Q&A. So really just a quick overview, and this is really a view we call network functions virtualization. That's one term. It's in essence a virtual machine type of thing. So a network function being like a switch, a router, a firewall, a DNS server, DHCP server, and virtualizing that function is really what NFV is all about. So it's kind of like creating a virtual machine. It's analogous, in other words, a virtualized network function, as it's called, an instance of a network function virtualized is equivalent to a VM, and we'll use those terms interchangeably in our discussion today. And these are instrumental to software-defined networks, which you are enabling these network functions through software, through the virtualization process, and you're also therefore able to configure them and really define your network through that software and through configuring that software that you've instantiated in your virtual network. And then software-defined WAN, this is really a service provider type term, which really deals with really pushing the software-defined aspect out to the edge and being able to define and really route and also provide additional services out to the edge and customer networks. So the benefits that SDN, NFV, VMs, virtualization in general offer to customers is really the speed of provisioning, So that agility that I mentioned. So being able to bring up a DNS server, a router, for example, on a moment's notice. So taking minutes as opposed to days or weeks, and really from even a service provider perspective, deploying customized hardware and software for specific telecom type service is a very lengthy process and rather expensive, whereas with the virtual world, it becomes as simple as a few mouse clicks and being able to instantiate new functions as needed. Flexibility, obviously, because of that speed and the variety of services that are available, and we'll talk about kind of chaining these services together to offer kind of a broader service that's comprised of these sub-services, offers a lot of flexibility to organizations, whether you're a service provider or an enterprise. And that also affords you greater agility and control in terms of adapting new services, introducing new services, again, whether it's to your enterprise users or constituents or your service provider subscribers, and being able to control those services with greater ease through software. And then, of course, the flexibility and being able to reduce costs because, again, implementing a common hardware that runs multiple services or multiple network functions is typically a lot less expensive than buying special purpose hardware to perform those various functions. I mentioned service chaining a moment ago, and really what that means is that you've got these different functions that you might want to provide. Let's say web acceleration, and then maybe you want to add like a DNS firewall type of service element. And so maybe you want to chain these services together so that a given customer's transaction kind of bypasses these service elements. And part of the benefit of NFV or SDN is that I don't have to buy big iron, so to speak, for service element 1 and service element 2 here. And I can actually use common hardware. I can instantiate a virtual machine or a virtualized network function. Again, I'll use those terms interchangeably, but I can instantiate multiples of these that perform common elements and really chain these together through the creation of these different elements. The three shown in the service element 1 are, let's say, that web acceleration application. So I can just, if I need more capacity, I can just bring up another VM, add it to my service element 1 pool, so to speak, and be able to deploy that as needed. And likewise with my, let's say, DNS firewall service on the element 2, I can also bring those up and down as needed. So you see where I can offer a variety of services by chaining these services together, which gives me that agility and control and flexibility. And then I can also manage the capacity dynamically through the ability to create and bring these elements down. Now we'll see how DNS itself plays a role in this service chaining when we talk about that in a little more detail, but basically being able to go from service element 1 to service element 2, as we'll see, DNS plays a critical role in that. But before we jump to that, let's just take, again, a very high-level view of kind of the networking aspect. So here you've got, very high level, you've got, talk about 50,000 foot, you've got three clouds here. So you've got the enterprise in the lower left. That's typically, obviously the enterprise internal network, we'll call it, internet, and then, of course, the public cloud. And really the traditional case, pre-cloud, I guess we'd say, you had the enterprise, and then, of course, when the internet came along, you had people connecting to the internet, which is all a good thing. And so we've got this connection to the internet, and I've got this little glob inside that enterprise cloud that shows kind of a mix of the internet address space, let's call it public space, enterprise public IP space, but it's really managed by the enterprise, so it's kind of a gradient shown there where I've got a mixture. Then you can also use the public cloud to, in essence, extend your enterprise network. So for additional capacity overflow requirements, for example, or just to deploy certain applications in the cloud, and a public cloud meaning, BT Cloud Compute, AWS, Azure, etc., those types of services. So you can basically, in essence, extend your enterprise networking into that. And that's address space that you would have to manage and keep track of. And then you've got really, leveraging public cloud resources to make them internet reachable. So here we have kind of a tri-gradient here where we're using internet space, internet reachable space, public space in other words, but it's really managed by the public cloud provider because it has to route to the public cloud, but it's also in essence tracked by the enterprise. So you've got that aspect of the address space within your public cloud that's public facing, internet facing, that really has that multi-dimensional aspect that one needs to be careful to track and manage, so that you're assured that you have that internet presence for those public cloud resources that are representing your services that need to be internet reachable. So this just gives you kind of a high-level view of these three elements and how the address space might be affected, and how you might need to track different aspects of this address space, and we'll talk about that here. So your enterprise private address space, so certainly your non-cloud, your traditional network, remote branch data center space, managing that through whatever means you use today. A private cloud, let's say you're using VMware or Oracle VM or some other sort of Zen hypervisor within your environment, just for the efficiencies that we mentioned in terms of leveraging common hardware for multiple applications and elasticity. So that also would typically leverage your enterprise private IP space. And then again, your enterprise extension into the cloud, the public cloud. So that kind of that line along the bottom of the chart we saw going from the enterprise to the public cloud, where you're still managing your own address space, your own private space, but it's within the cloud resources. From a DNS perspective, typically this enterprise private address space is going to entail internal domain names, so internally reachable hosts, because they're private address space, not internet routable. So they should be resolvable internally only. Enterprise public space, this is also address space that, let's say, you would get from your ISP or your internet registry. And this, of course, would be for your internet-facing servers, so between the enterprise and the internet. And it's also, of course, internet resolvable DNS. It may also be internally resolvable to access that if desired. And then the public cloud address space. Again, this is going to depend if, going back to the private network extension, that of course would use the private address space as we discussed. But if there are aspects of the public cloud that you're leveraging for internet reachable resources, this is really where you'd have that address space that the public cloud in essence owns or manages. It's internet reachable, but it's really in essence attributed to the enterprise. So as an enterprise, you need to track that and be able to make sure those resources are reachable. And again, internet resolvable DNS. So that's kind of another view of those three clouds, just kind of to summarize the different kind of classes of address space that need to be tracked and managed. So if we look at, let's kind of drill down now into how the IP addressing for an individual virtualized machine or virtualized network function would be processed. And we kind of start with the basic three-step process of the preparation phase. I need to instantiate a VM, the actual bringing up of the VM, and then the end result being a VM having been created. And so, as we go through this in a little more detail, how does this affect how you might need to perform this function? Well, first you want to define the subnet on which the VM would be provisioned. If you've just got one subnet out there in your cloud, that's fine. Your private cloud in this case, we're going to look at that first. Then it's easy, but otherwise you might need to look at where you've got address space that you can assign. Determine your address method. Let's say it's manual, so if you're tracking it in spreadsheets, for those 40% of you that said you're planning to use spreadsheets, this is where you would go to the spreadsheet. Okay, I've got address X. Is it free? You might want to just make sure. Maybe you need to ping that address or check with the VM system orchestrator to make sure that it's available. And if it is, assign that address as part of the instantiation when you create the VM, and then either manually send the DNS update or use the orchestrator function to do that. And that would be a way that you could automatically create that, well, semi-automatically, let's say, create that VM by assigning the address manually. Now, you could also use DHCP, so if we kind of follow along that same path, a lot of the VM infrastructure provides DHCP, or if you've got a virtual DHCP server running within your environment and you've configured it with corresponding address pools. Here it's more of an automated network function, assuming your DHCP server has enough capacity in terms of the address pools. And so that's really where you would check. If you don't have enough, if you do have enough capacity, then you would basically just define, and really you wouldn't have to do anything because the address space is already provisioned. But if there was a case where you didn't have an additional free IPs available in your address pools, you would need to maybe allocate either a bigger pool, expand the size of the pool you have, or create even a new subnet and have an address pool assigned to that. a little more laborious, but again, it's just part of the IP address capacity management process that also entails not only non-cloud environments, but as we see here, in the cloud as well. So if everything is preset already and the capacity exists, the DHCP server simply assigns the address, and it can be configured to update DNS so that that address assignment is mapped to the DNS server, and you end up with the VM being instantiated with DNS entries. Here's kind of a look at that unified process here. So you can see that it's rather complicated. All this just to assign an address and update DNS. So you know, is there, one might be drawn to think, well, is there a way to make this process a little simpler? And before we get to that, let's look at a case with the public cloud. This is a slightly different. Now you're actually asking the public cloud provider, here's my subnet, but you know, I need to assign a given host an IP address, and here's really where the public cloud infrastructure, based on the policies of the implementation of that infrastructure, is going to dictate, you know, what address gets assigned maybe, or really when that address is available or free when you unassign that address. So some cloud providers offer this kind of this holdover time, where when I free up a VM, it actually does not free up the IP address instantaneously. It may hold over for minutes, just to let it kind of time out, if you will, of caches or what other infrastructure that the cloud operator might have. So in this case, it's more of just initiating the process with the public cloud provider, and then being able to then identify what address was assigned based on that. So basically, you can ping the cloud provider, ask what address is available, okay, create a VM with this IP address, and then you can update the IPAM repository with that, and you end up with the VM created. So in some sense, it's a simpler process, certainly, fewer boxes, that's for sure, but it's also more of a dependency. And if we look at this kind of as an example, Sapphire Cloud Automation Appliance, where you can basically use an automation tool to create a virtualized network function instance, which would then make a REST API call to our CAA appliance, which would then make the request into the public cloud environment for a free IP address, identify the free IP address, and create the instance with that IP address. Upon success, then update our IPAM solution, which is called IP Control from BT, and we would add that to the repository and report that back to the automation, cloud automation tool. So it's really a way to plug in an IPAM automation technique into your public cloud provisioning process to associate IP addresses on the fly, and to also keep track of them so that they're available for when you need to troubleshoot or access a host or what have you. So before we look at the benefits of this automation, let's take a look at what might be some of the repercussions of mismanaging the IP address space. So just kind of taking a step back, well, why do I need to track IP addresses? Why can't I just use a spreadsheet, or why do I even need to track them at all? Well, you may end up with a case where you are unable to provision a VM or a VNF on the network. Obviously, if your subnets are fully occupied, you don't have an IP address you can assign. It won't do you much good to create a VM or VNF if it can't access or be a member of the network. You may end up with suboptimal IP address utilization, so depending on your subnet allocation mechanisms and your pools, and you may not have allocated them to the right accessible subnets for the VM or your cloud infrastructure. That could end up with a misalignment of capacity to the needs of your user community. It could be an unreachable case where you've got maybe a duplicate IP address assignment. If you're not tracking IP address assignments, you could end up with, if DNS isn't updated, it could be unreachable by name as well, as we'll see. So that I look up a given name and I can't resolve that. So if DNS isn't updated, and that's important not only from accessing that individual host, but also part of this service chaining that we talked about before, because I could create, let's say a new web acceleration VM within my service element 1, let's say, and I could just add that IP address of that instantiated VM to a name, let's say service element 1.yourenterprisename.com. And so what that would do is that enabled the predecessor VM in the chain to just look up, okay, well, what's the next service element in this chain here? I don't have to look up the name of the individual VM. I can just look up the service name, and in essence, all of those VMs that are attributed to that service can get resolved through DNS, and I can access the one that I need to connect to kind of chain the service along the way. So DNS is critical not only for reachability of a given host, again, but also for the service chaining aspect. Troubleshooting, you really need to know your IP address space, what IP is assigned to what device, really in a manner other than querying the cloud. Let's say your cloud infrastructure is down, or your link is down, or what have you, and that's really the time when you might need to, let's say, access it through the internet or some other network to access that to perform some troubleshooting or what have you, and that's really where you would need to know what IP addresses are associated with those different resources in your cloud. And then, of course, wasted address space reduces capacity. It really comes back to the address utilization, making sure your address space is used where it's needed by the capacity requirements for keep your enterprise running. Some of the automation techniques, address capacity management, I mentioned this in terms of just making sure you've got IP addresses where you need them, when you need them, and this can be facilitated through discovery, and that discovery can comprise, ARP lookups or pings or polling your cloud application, your cloud API, for example, and also applying thresholds to those and being able to trigger a case where, okay, well, this subnet's got about 2 addresses left, so maybe it's time to think about deploying or adding a new subnet to that instance. Subnet allocation, speaking of which, providing a way to do that simply is also important. So as part of the elasticity of VMs, being able to turn them up quickly because of the need for capacity. Likewise, you want to apply the same thought process to creating subnets. So being able to really just make a quick, add a new subnet that's in this block of addresses I've attributed to my cloud, and have that done automatically for you without having to break out the spreadsheet, do the binary math, and figure out what's the next subnet that is free and assign that. And then being able to split and join, that's just a subnet operational technique that you can actually shrink subnets, split them in half or what have you, or join them together to make them larger. So that, in addition to allocation, is just another technique to manage your capacity. Individual address assignment, we kind of walked through this through our flowcharts there in terms of automating the IP address assignment along the way. So as I'm using my orchestrator or my cloud automation system, I don't have to make a manual step in that process to manually enter the IP address. If I can leverage my IPAM repository and plug that in, so to speak, to the process, I can really streamline that and have the orchestrator do its thing in terms of instantiating the VM of the appropriate specifications while tying in the IPAM system to automatically assign the IP address and DNS name in the context of where that VM has been created. And then DNS, again, DNS is critical not only for the individual host resolution of that given VM, which is important for troubleshooting, certainly, but also associating that with a service element for the service chaining benefit that that service flexibility offers you. So if we look at, again, summarizing the IPAM services that are critical to automate for your cloud to fully streamline your cloud operations and provisioning, really the IP inventory is critical, from being able to track your IP assignments presently, so you know what you've got out there assigned. What is not assigned is equally important, so that you know how much capacity you have available. If you've got some big initiative coming up or a big surge in capacity where you're going to need a bunch of VMs in a heartbeat, knowing that you've got that address space available is great, can put your mind at ease, certainly, through that process. If you don't have the capacity, being able to allocate subnets to add capacity is certainly very important as well. And doing that in a simple or automated manner can also streamline the process. Individual host assignment, as we've seen, configured through static. We walked through the DHCP process, and also the public cloud, the discovered, so to speak, shared status, where you've got the cloud essentially assigning the IP address, and you're in essence determining what that is or what that was based on what the public cloud considers as free address space. And then, of course, DNS updates. So these are really the key elements of IPAM services that are critical for managing your pan-enterprise IP address space. So not only your data centers and your remote sites, but also your private clouds, your public clouds, providing that visibility across the organization, which is really one of the core benefits of having IPAM manage your multi-platform network. So the automation, the visibility, adding security through the ability to really control administrator access is one aspect of that, but also additional services such as being able to set up security options on your network elements, like DNS firewall, for example. Being able to configure that is very important to extend the same level of controls and security you have in your enterprise network today out to your private and public clouds. And that can be, of course, instantiated through virtual appliances, such as our virtual Sapphire appliances that we offer from BT. Reporting, auditing, administrator scoping, I mentioned, scalability, all very critical elements to the cloud, being able to track who did what when. Things are moving very quickly, and being able to track all that and maybe go back for forensics analysis or, again, troubleshooting, tracking that's very important for that. Adaptability, managing it to your network. I mentioned the CAA basically going to allow you to adapt those workflows. I just showed you one example there in terms of assigning an IP address to a VM, but that'll be very adaptable for you to really adapt to your cloud environment and to your process workflows for assigning subnets, IP addresses, and also discovery. Provides integration either through a graphical interface to have users looking at the address space and managing portions of your network, and also through the REST API, which facilitates the automation and the rapidity of making those updates. Cost and time savings, of course, is a fallout of that benefit in terms of just electronically automating everything, and it just happens. And that also saves on cost and certainly time. And then the improved troubleshooting we mentioned in terms of having that inventory, that repository available, especially in a time of troubleshooting when you may not have access to it from the end device you're trying to troubleshoot. So if we look at the BT Diamond IP solutions in this regard, I mean, certainly we have the private and public cloud integration, IPAM integration capabilities. Today we've got the enterprise, the private cloud, we're moving into public cloud, as I mentioned, automated VM, VNF IP assignment. So through the cloud automation appliance, this can be greatly facilitated in terms of tying in the IPAM assignment with your overall cloud instantiation VM processes. Discovery and reconciliation, this can be configured in a number of ways, whether it is through, as I mentioned, pings or ARP, but also through API calls to identify assigned addresses in accordance with what the authoritative authority, let's say in a public cloud, their platform has recorded, and then being able to pull that into your IPAM database to provide a visibility to that. So again, you've got that pan-enterprise perspective on your IP address space. Automated DNS updates, again, is critical not only for the host accessibility, but the chaining of the services together. So automating that is also a big time saver. So really the comprehensive aspect of IPAM DDI, what Diamond IP has provided for over a decade now in terms of IP v4 and v6, discovery, allocation, assignment, some of those other functions like splits and joins, as I mentioned as well. It's all quite easy to do through a single mouse click or an API call to assign the next subnet or the next set of subnets, the next IP address, etc. There's not a manual process required there in advance, so it's all integrated functionally. And then reclaim is important. Again, we talked about capacity management, making sure the address space you have tracked is actually accurate with respect to what's being used in your cloud and non-cloud environments. So being able to look at those addresses that perhaps are maybe recorded as being used but are not actually being used, and being able to reclaim those and be able to do that not simply by just deleting a device, but by actually looking at it and getting a robust sample of its availability and being able to pull that into the available pool should it be truly not being used. Alerts are useful in terms of obviously being notified in advance of a potential capacity, reaching your capacity in terms of the addresses, the subnets, etc. and that can tie into a manual update process or even automated to allocate additional subnet and IP address capacity based on templates and so forth that we provide in the system, so it can be fully automated in that regard as well. And then, of course, the network services support, which is also key in terms of DHCP for V4 and V6, as well as DNS, and being able to support those from a virtualized ability as well as hardware, as well as multi-vendor software. So I mentioned the virtual DHCP DNS appliances, so you can instantiate these as virtualized network functions in your cloud, and we're vastly expanding our platform support next quarter. So please look for that, and we'll have a lot of information about the various platforms that we'll support there. And also IPAM, so the IPAM system itself, the cloud automation appliance that I mentioned, also can be virtualized. And then, of course, the reports, administrator controls, APIs, workflow, the scalability, the other elements that I mentioned as benefits certainly apply to the Diamond IP solutions as well. So I'd just like to invite you to look at our resources for additional information. So we've got, in particular, our cloud network services, a core network services cloud automation white paper, but that provides some good information in terms of how we can help you provide automate your cloud environment with respect to automating the IP address management aspects of that. And then we've got several other white papers, books, as Mike mentioned, and of course we also have a presence on LinkedIn and our BT Let's Talk blog, as well as various web resources. So with that, we will turn it back over to Mike, and let's see what kind of questions we have.
Okay, thanks, Tim. Again, to ask a question, you may type it in the chat pane on your WebEx application, and we have a few questions here, so why don't we just jump right into them. The first question is, can I just set up DHCP and have it update DNS? So it's dynamic updates, or what they're talking
Yeah,
about?
I guess so.
Yeah.
Well, yeah, I mean, that is certainly one of the aspects of it. You can configure your DHCP pools with, as you allocate subnets within those subnets. Maybe it's a whole one big DHCP pool, but probably you've got at least a few addresses in there that are for your routing infrastructure, your routers and switches, etc. But if it's largely dynamic, you could, basically set up DHCP, and you could also use your cloud platform DHCP, typically automated address assignment. And then, depending on the implementation of that, assuming they also support DNS, then certainly that might be an option for you. But I guess, in terms of, that definitely helps the automation, but just in terms of, troubleshooting and tracking and auditing and things like that, again, it's going to depend on the implementation that you have there with respect to being able to, let's say, look up who had a given IP address, 2 weeks ago for some issue that maybe arose, or maybe there's a problem and you need to access a given device and you can't access the DHCP server lease file to get the current address assignment. So there's it certainly would help on the automation front up front, but from the management perspective, being able to manage your address space, it could leave you a little bit wanting for additional functionality. So having the IPAM system really on top of that just gives you the ability to provide that additional ingredient for tracking, auditing, compliance, reporting, and troubleshooting that you might find beneficial.
Yeah, I get to see everything in one place.
Yeah, exactly.
Okay, thanks. Next question is, how does NFV relate to SDN, or software-defined network?
Mm-hmm. Yeah, so this probably came up on the couple beginning slides there, but yeah, NFV is network functions virtualization. So again, it's really the virtualization, or putting into software, if you will, network functions, like let's say a DNS server. So with SDN, it really again is truly software definable network. So you've got this generic hardware, let's say x86 hardware out there in your cloud. Let's say it's a private cloud, and SDN applies to private and public networks. But basically, you can then by using software create a DNS server out of the blue, so to speak, and instantiate that through your orchestrator, and then configure it likewise through your IPAM system, again through software, and then be able to define how you want your network to behave in essence by that configuration. So whether it's a DNS server or a router, firewall, other element that you can instantiate in your cloud by being able to create it on the fly and be able to configure it using the corresponding management system. You can really govern how your network behaves through that software function. So that's kind of the idea of software-defined networks is kind of the concept, the overall concept, whereas NFV is really kind of the individual elements that you're creating in your software-defined network to perform specific functions and then configure them accordingly.
Yep. Okay. Great. Let's see. Next question. What is a hybrid cloud and how useful is it?
Well, a hybrid cloud is the term. Sorry, it's the term used to describe a networking environment where you have both private and public components. So you might have a VMware in your data center. Let's say you want to virtualize your data center, and then maybe you want to leverage a public cloud for, let's say, excess capacity requirements. You might have a VPN to your public cloud. It really is an offshoot of your data center or your private network. So that would be considered a hybrid cloud. So that's just an environment where now you've got a mixture of platforms, and maybe you've got good old traditional hardware in different offices as well. And really, so the concept is you've got this mixed environment, and they've all got IP addresses and DNS names, and being able to manage that together is very important. So a hybrid cloud is very useful. It can certainly give you that adaptability and a lot of the benefits that the cloud provides, and also the pay-as-you-go element also helps from a financial perspective, that you're only paying for what you use. And so the public cloud typically is seen in many cases as kind of a capacity overflow ability, and that can be very useful to organizations. But again, just being able to track the IP and DNS information is very important in that environment.
I've heard customer talk about security as well, where they want to have their private cloud with all their critical data and critical functions within the private cloud in their own data centers physically, to lock that up, and the public cloud clouds for more non-critical, mission critical type services as well. So I think that plays into it too, potentially.
Yeah, certainly.
Each customer is different, so.
Yeah, absolutely. But that's not to say that security is not important in the public cloud, but certainly having kind of consistency, I think, is important. So if you've got like a virtualized DNS server, let's say Sapphire, you've got the same set of features, whether it's a hardware appliance, whether it's in your private cloud or your public cloud, and so you can implement those security features like a DNS firewall or what have you, regardless of where it's implemented within that hybrid cloud and non-cloud environment.
Yeah, good points. All right, let's see. Next question, which kind of leads right into our discussion we were just having. Isn't the cloud just the internet?
Well, this is, I apologize. I saw this. It's a valid question. I think I think when this whole cloud concept came out, it was just kind of like, well, what's the big deal? It's really just the server and the internet. But I think when you drill into it, even a little bit, it's a whole realm of services that reside on top of that. So it's not just servers on the internet, but it's really the whole virtualization aspect. The ability to bring network functions up and down on a moment's notice, and so it gives you that flexibility. It gives you that speed of provisioning. And in essence, also, it's an extension of your private network of you using private space with a VPN into the cloud. Really gives you that, and again, that elasticity, as we call it. So it really is, it's leveraging the internet, typically, for your connection there, or maybe you're using private network or even private servers. But the cloud really is, it gives you that extra layer of manageability that is really differentiated, so to speak, from just quote unquote generic internet. So I think that's really the difference in terms of what the cloud is versus the internet in a nutshell.
Yep. Okay. Thanks. Let's see. I think this next question has to do with more IP address management, and the question is, can I just run discovery or discoveries after the fact to gather IP assignments?
I think that's a good point, and in fact, it's actually a recommended approach, just in terms of being able to just make sure that what you think is out there is actually out there, and that's not only from an address integrity perspective, but also from, I mentioned reclaim a little bit earlier, and making sure an address is still occupied when you think it is. So I think that's a great way to do reconciliation. I think using that strictly as your means of managing IP space may not be the best way, because it's really a snapshot, and it may not give you, unless you're tracking kind of the history of that, which hopefully, if that's all you're doing, hopefully you're tracking the history, because if you are unable to do a discovery, let's say, you're not gonna have the ability to identify what is on what IP address, and again, from a troubleshooting or reachability perspective, it may present an issue. So yeah, I think the discovery, whether it's through pings or whether it's through API calls, are very important. But I don't think it's the sole means of managing your IP address space. I think it's a critical ingredient, but yeah, it fits in with the overall picture.
Okay, great, thanks. I think the next question is around DevOps. Question is your cloud automation appliance similar to Ansible, which is a DevOps product?
Yeah, Ansible and similar products, Puppet and Chef, and there's a myriad of products out there that really help on the DevOps side and help you to manage multiple server configurations or other network element configurations in a very streamlined fashion. I would say that our CAA is not as broad as an Ansible. I mean, Ansible is very flexible, adaptable with respect to just working with a wide variety of network elements. Ours is more focused on DHCP and DNS and IP address management in particular. So I would say the CAA is a critical component to plug into your DevOps environment with respect to automating IP assignments. So as your Ansible or similar product or system is performing these functions on your network, for those that involve IP addresses, either assignments or de-assignments or modifications or moves, that's really where the CAA from BT can plug into that process to be able to really provide the integrity of the address space, to be able to have it in the repository, to be able to make updates to the repository accordingly to the operation that's being performed. So it is kind of like Ansible in the sense that it automates and it can be configurable, but it's not quite as all-encompassing. I would say it's more IPAM focused, let's say.
Okay, let's see. Are there any more questions? I don't see any more questions on the chat pane. I think we hit them all.
Today.
We did. Very nice. Okay, good. We're actually ahead of schedule then. So we're going to wrap up the webinar then. I'd like to thank Tim for his presentation today, and I'd like to thank all of you for taking the time out of your day and participating in this webinar. We hope it's been beneficial in helping you to understand how automating core network services can improve your cloud operations. Have a great day, evening, or afternoon. Thank you.